Welcome back to a brand new deep dive. We are so glad you could join us today.
Yeah, we've got a really fascinating one for you.
We do, because today we're looking at a scenario that challenges a lot of our basic assumptions about how global business actually works.
Right.
I want you to imagine a massive industrial behemoth. We are talking about a company that's been around for 178 years.
A long time.
Physically building infrastructure, manufacturing equipment, and just laying down the industrial backbone for countries all over the planet.
Real heavy industry stuff.
Exactly. So the central question for you to think about today is this. How can a company of that sheer physical weight and size actually decouple its financial growth from its resource consumption?
It's a huge question.
Right, like how does an industrial giant grow its profits while aggressively shrinking its environmental footprint?
It honestly sounds like a contradiction in terms at first glance.
Yeah, it really does.
Because traditionally, when we think of industrial expansion, we instinctively think of extraction.
Right, more factories.
Exactly. More factories mean more energy burned, more raw materials pulled from the earth, and inevitably just more waste left behind.
Yeah.
But the data we're parsing through today suggests a completely different economic model is operating right now. And it is happening at a massive scale.
It is. So let's look at today's stack of sources, which come directly from Siemens.
Lead player.
Huge. We're analyzing their newly released Siemens Impact 2025 report alongside their incredibly detailed 2025 sustainability statement.
And these are dense documents.
They are. And to be completely transparent with you listening, when we first pulled a stack of corporate sustainability reports, I naturally braced myself for, a wall of corporate buzzwords.
Oh, absolutely. The usual PR spin.
Exactly. But what we found instead is a set of highly rigorous, data-driven engineering documents.
And that data-heavy approach sets the exact mission for our deep dive today.
Right.
Instead of just reading down a list of broad environmental, social, and governance goals, which, let's be honest, can often feel detached from reality.
Very detached.
Our mission is to unpack how a massive organization actually operationalizes sustainability on the ground.
We want to understand the mechanics.
Exactly. How you combine the digital world with the physical world to turn massive climate challenges into measurable, profitable actions.
Okay, let's unpack this, because the first major concept in these reports completely reframed how I even look at corporate responsibility.
It's a big shift.
We are all used to hearing about a company's footprint, right? The pollution they directly create.
Right, the standard metric.
But Siemens focuses heavily on a metric they call the handprint.
It's a really vital distinction in modern environmental accounting.
Tell us about that.
Well, the footprint is the negative impact you leave behind. But the handprint is the positive impact you help others achieve.
I love that visualization.
Yeah, and in these documents, Siemens measures this handprint through a specific metric called customer avoided emissions, or CAE. So instead of merely tracking the carbon generated within their own walls, they are rigorously calculating the emissions that their products, hardware and software, allow their customers to avoid generating in the first place.
And the scale of this handprint is genuinely massive.
It is.
According to the 2025 report, Siemens enabled its customers to avoid 694 million metric tons of CO2e cumulatively.
That is a staggering number.
And they have set a firm target to surpass 1,000 megatons by 2030.
Wow.
Just to put that 1,000 megaton target into a real-world perspective for you listening, that is roughly 1.5 times the annual emissions of the entire country of Germany.
That really puts it in perspective.
Right. And just so we're all on the same page with the terminology here, when the report mentions CO2e, they're talking about carbon dioxide equivalents.
Right, basically bundling all greenhouse gases into one standardized metric.
Exactly, just to make the math clear.
What's fascinating here is the inversion of impact that occurs when a tech company successfully scales that handprint.
The inversion.
Yeah, look at the specific data for the year 2025 alone. Siemens enabled their customers to avoid 199 million metric tons of CO2e in that single 12-month period.
Okay.
Now, compare that to the footprint Siemens generated across its entire global value chain. That was 155 million metric tons.
That's wild. And when you say their entire global value chain, that covers scopes 1, 2, and 3, right?
Yes.
Meaning everything from the direct fuel burned in their own facilities to the electricity they purchase, all the way down through their supply chain and the eventual use of their products.
Precisely. They are accounting for the total life cycle.
Got it.
And the data shows they've crossed a critical inflection point where their technological handprint is demonstrably larger than their total operational footprint.
That is a huge milestone.
It really is. And it's crucial to note how they are doing this. They aren't relying on massive carbon offset purchases or planting forests to balance the ledger.
They aren't just buying their way out of it.
No, this inversion is driven by pure industrial efficiency, deploying software and automation that drive deep electrification in other people's factories and power grids.
That's a massive shift in how you account for corporate impact.
Definitely.
But it makes you wonder, if the tech they are selling is so revolutionary, are they actually doing the hard work in-house?
Right. Do they eat their own cooking?
Exactly. Do they use their own tools?
Yeah.
The sources actually address this by looking at the Siemens manufacturing plant in Fürth, Germany.
This is a great example.
They basically treat their own facilities as beta testers and power users for this technology.
The Firth facility is a brilliant case study for this exact reason. It is a dense, high-volume manufacturing site producing industrial controls and electronics.
So it uses a lot of power.
A lot. And between 2019 and 2023, they implemented their own holistic energy management systems.
What does that look like in practice?
Well, this wasn't just swapping out a few old machines. It involved installing massive arrays of power meters, connecting the entire factory floor to central software, and using algorithm-based optimization to manage how energy flowed through the building in real time.
And the performance metrics they logged are stark.
Right.
Over that 4-year window, the Firth plant increased its manufacturing output by 145%.
Unbelievable.
They more than doubled the physical goods they were producing, but at the same time, they reduced their energy use per unit by nearly 2/3.
Yeah.
And they cut the CO2 emissions per product by over 70%.
It completely dismantles the century-old industrial assumption that increased output inherently requires a proportional increase in energy consumption.
It really does.
And this performance has been externally validated. The World Economic Forum actually named the Firth plant a sustainability lighthouse.
Which is an incredibly rare designation globally.
Extremely rare. Because of this digital integration, the facility is currently on track to reach net zero operations by 2026. That's a full 4 years ahead of the broader corporate pledge.
So mechanically, how are they achieving a 2/3 reduction in energy while doubling output?
It's a good question.
You can't get those margins just by turning the lights off when you leave a room.
No, absolutely not.
The reports point squarely to software, specifically the deployment of digital twins and industrial AI through their open digital business platform, Siemens Accelerator.
Right, the digital twins are key here.
For anyone listening who might not be deep into industrial engineering, the best way to conceptualize a digital twin is to imagine playing a hyper-realistic simulation game.
Something like SimCity or a factory builder.
Exactly. But in this case, every single tweak you make to a virtual machine or a virtual ventilation system translates directly to actual megawatts of power saved in the real world.
That is a highly accurate conceptual model. The foundational philosophy of a digital twin is that you optimize entirely in the digital world before you ever pour a single drop of concrete.
Or cut a piece of metal.
Exactly, in the real world. By building an exact virtual replica of a physical asset and feeding it real-world data, industrial AI can run thousands of simulations.
Basically running the factory in the matrix.
Yeah. It can identify subtle design flaws, predict when a specific bearing might fail, and optimize energy flows in a completely risk-free digital environment.
To see how that translates to the private sector, we can look at the Coherent case study in the 2025 report.
Coherent, yes.
They're a major player in materials and optics for semiconductors and lasers, and manufacturing lasers is an incredibly energy-intensive process.
Very high energy draw.
You are dealing with highly controlled clean rooms and specialized equipment that draw massive amounts of baseline power.
The challenge for a company like Coherent is simply gaining visibility into that massive energy draw across multiple global facilities.
Because it's just so fragmented.
Right. So they partnered with Siemens to implement a cloud-based platform called Building X. The platform acts as a central nervous system, visualizing and managing vast amounts of fragmented energy data from all over the world.
The financial and environmental returns on that visibility are huge. By essentially organizing and acting on their own data, Coherent achieved $16 million in energy savings over a 5-year period.
That's massive.
And looking specifically at fiscal 2025, that software optimization helped them cut 264,000 metric tons of CO2e.
It is a perfect example of how data organization directly yields physical efficiency.
Definitely. But this technology isn't just for private factories, it's also being deployed to overhaul public infrastructure.
Right, the public sector is huge for this.
A great example in the sources is Elvia, the largest power grid operator in Norway.
This raises an important question about the reality of the global energy transition.
How so?
Well, Norway is a unique environment because they have the highest penetration of heat pumps and electric vehicles anywhere in the world.
They are way ahead of the curve.
They are. And because of that, their grid is experiencing unprecedented dynamic pressure that it was never originally designed to handle.
Right.
Now, the traditional 20th century solution to grid congestion is simply to dig up the roads and lay down thousands of miles of new, highly expensive copper wire to handle the physical load.
Right, but physically expanding the grid like that takes years, costs a fortune, and disrupts entire cities.
It's a nightmare.
Instead of defaulting to more copper wire, Elvia deployed a software solution called GridScale XLV Insights.
What did that do for them?
They built a comprehensive digital twin of their existing low-voltage grid. By using smart data to map exactly where the power was flowing minute by minute and pinpointing exactly where the invisible bottlenecks were occurring, they managed to increase their existing grid capacity by up to 20%.
Wow.
And on top of that, they reduced outage times by up to 30%. They fundamentally accelerated the energy transition simply by making their legacy infrastructure smarter.
It perfectly illustrates a core tenet of modern engineering. The cheapest, most sustainable infrastructure you can possibly deploy is the infrastructure you don't actually have to build.
Because you've learned how to optimize the assets you already possess.
Exactly.
Here's where it gets really interesting, though. We've focused heavily on energy grids and software data, but the reports also pivot aggressively into physical materials.
The tangible stuff.
Yeah. They detail the transition from a traditional linear economy, the old model where we extract raw materials, manufacture a product, use it, and eventually throw it in a landfill, to a circular economy.
Right.
How does high-end technology actually prevent physical waste?
The primary mechanism Siemens is using to force this shift is a rigorous framework called the Siemens Ecotech standard.
Ecotech?
Yes, and the adoption is scaling rapidly. They actually doubled the number of products meeting this standard in 2025 alone.
So it's not just a buzzword.
It isn't just a marketing label at all. To earn the Ecotech designation, a product must provide a highly transparent environmental product declaration, or EPD.
Got it.
It strictly mandates that the product is manufactured utilizing 100% renewable electricity.
Okay, that's a high bar.
It is. And most importantly, it must quantitatively prove that it outperforms baseline market standards in either sustainable material usage, optimal energy use during its life cycle, or value recovery when it reaches the end of its life.
And the practical applications of this circular design are fascinating. The report highlights a Florida-based company called Hattie that manufactures furniture.
Oh, this is a wild story.
It's so cool. They have completely discarded traditional manufacturing techniques. There are no wood shops, no standard assembly lines, and no massive warehouses full of pre-built inventory.
So how do they build it?
They use Siemens digital manufacturing software combined with massive, large-format 3D robotics to print furniture entirely from recycled plastic.
It represents a shift to a native digital supply chain. By printing on demand, they eliminate the need for traditional molds.
And no toxic adhesives either.
Right. They don't use toxic adhesives to bind different materials together, and they completely bypass the environmental cost of storing and shipping excess inventory.
The efficiency gains are massive. The software guides the robotics to print 100 pieces of furniture a day per robot.
Wow.
Which results in a 50 to 75% savings in raw materials right out of the gate.
That's incredible.
But the real magic happens at the end of the product's life. Because a chair or table is made from a single adhesive-free material, it never goes to a landfill.
Oh, they recycle it.
Better than that. When you are done with it, the piece is literally shredded back down into raw plastic pellets and fed right back into the robot to be reprinted into a new design.
That is a completely closed-loop system.
Exactly.
If we take that concept of extracting maximum value from limited resources and apply it to an even more critical domain, we have to examine global water stress.
A huge issue.
The sources present a truly sobering statistic. By the year 2030, global demand for fresh water is projected to outpace supply by 40%.
That is a staggering deficit for a fundamental resource.
It is a profound crisis, and what makes it exponentially worse is the inefficiency of our current distribution networks. Currently, an estimated 30% of all treated, clean drinking water is lost to pipeline leaks before it ever reaches a consumer's tap.
Wait, really? So nearly a third of the water we spend massive amounts of energy treating and pumping is just bleeding into the dirt.
Exactly.
That's terrible.
It is. But this is another area where digital intervention is proving highly effective.
How so?
The reports outline how VA-SID, a major utility in Sweden, is tackling this using an AI application known as the Seawall Leak Finder.
Okay.
By feeding continuous data from smart flow meters into the AI, the software can identify pressure anomalies and detect leaks as minuscule as zero point 0.2 liters per second.
Just a trickle, basically.
Right. These are micro leaks that would traditionally go completely unnoticed for years until they caused a major failure. By flagging them immediately, the utility has been able to cut its water losses by up to 50%.
And the predictive power of this tech extends to wastewater management as well.
Oh, yeah.
The sources highlight Yorkshire Water in the UK. They are deploying AI smart sensors throughout their sewer networks.
Predicting blockages.
Exactly. By continuously analyzing water level data and flow rates, the AI can predict a sewer blockage with up to 90% accuracy before any overflow or pollution event actually happens.
That's huge for the environment.
They are fundamentally stopping environmental contamination before it occurs, moving entirely from a reactive maintenance model to a proactive one.
It's a vital shift in how public utilities operate. But the reports are also very careful to ground all of this technological advancement in human reality.
Right. What does it mean for people?
Digital twins, AI leak detection, automated robotics, none of this infrastructure matters if it doesn't demonstrably improve everyday life and operate securely.
Which brings us to the final pillars of the 2025 statement: people, centricity and society, and ethics and governance.
The human element.
Exactly. The tech has to translate to the street level. A great example for you to visualize is your daily commute.
Everyone can relate to that.
Yeah. If you live in Berlin or the surrounding Brandenburg region, your transit experience is fundamentally changing. The Niederbarnheimer Eisenbahn rail network is actively replacing its aging, noisy diesel fleet with Siemens' new Mirio Plus H hydrogen trains and Mirio Plus B battery trains.
The engineering behind these trains is a major leap forward because they provide zero-emission transit on routes that haven't been fully electrified yet.
Right, because laying new electric lines is tough.
Exactly. They don't require the massive capital investment of building continuous overhead electric lines.
Makes sense.
By deploying this hydrogen and battery fleet, the regional network is eliminating the use of 5.5 million liters of diesel and saving 14.5 million kilograms of CO2 every single year.
Those are massive savings.
The tangible result for the public is drastically improved local air quality and a much quieter, cleaner commute.
But deploying these massive, interconnected public infrastructure upgrades across the globe requires serious regulatory and security frameworks.
Oh, absolutely.
You can't just plug a hydrogen train network or a smart grid into the cloud without rigorous governance.
If we connect this to the bigger picture, we have to examine the regulatory environment driving these markets, particularly the EU taxonomy.
Right.
For context, this is a highly detailed classification system designed to define exactly which corporate activities can legitimately be classified as environmentally sustainable.
And looking at this purely from a data and compliance perspective, regardless of the ongoing political debates surrounding European regulations, the EU taxonomy acts as a massive market filter.
It really does.
Multinational companies have to navigate it to secure public tenders and favorable green financing.
Right.
According to the 2025 report, 52% of Siemens' eligible global revenue aligns with these strict climate change mitigation standards.
Over half.
And when you look specifically at Siemens Mobility, the division manufacturing those hydrogen trains, an incredible 87% of their revenue is aligned.
Wow, 87%.
Yeah. That metric is heavily driven by products like their Vectron cross-border electric locomotives, which are engineered to shift heavy freight transport away from carbon-heavy trucking and aviation.
It reinforces the reality that environmental compliance is fundamentally a core business strategy today.
Definitely.
But the reports also address the inherent vulnerability of this strategy. When you digitize the power grid, automate the water supply, and connect the rail network to the cloud, you are simultaneously creating a massive, highly sensitive target for cyber attack.
Which is why the governance section heavily emphasizes that digital sustainability is entirely reliant on absolute digital trust.
You have to have security.
You cannot operate a smart grid if that grid is susceptible to bad actors. To address this, Siemens has implemented a rigid governance target to cover 100% of their relevant applications with Siemens Zero Trust cybersecurity protocols.
Zero trust.
Yeah, it is a security architecture that assumes no device or user is inherently safe, requiring continuous validation and encryption. They treat cybersecurity not just as an IT defensive measure, but as the absolute prerequisite for scaling any of these societal impacts.
So what does this all mean for you listening? When we look at this massive shift toward industrial AI, digital twins, and electrified infrastructure, how does it impact the average person?
Well, the sources point directly to a massive shift in the labor market. The transition is expected to create 78 million new jobs in the tech and green sectors over the next 15 years.
78 million? That's a lot of jobs.
And this shift requires a workforce with an entirely new set of skills.
This brings their corporate responsibility metrics full circle to human capital. It is an acknowledgement that you cannot simply install cutting-edge industrial AI and expect the existing workforce to intuitively know how to leverage it.
The technology is evolving much faster than traditional educational institutions can update their curriculums.
Exactly. Recognizing this widening skills gap, Siemens set a societal target to reach 3 million people with digital and sustainability education by the year 2030.
And the tracking in the 2025 report shows they are moving fast. They have already reached 1.12 million people.
That's great progress.
And these initiatives aren't just high-level university partnerships. They include accessible online micro-credentials in sustainable engineering and practical, hands-on vocational training programs in emerging markets like India.
Building the talent pool.
Exactly. They are actively trying to build the workforce required to operate the infrastructure they are designing.
It is a pragmatic approach to scaling technology. The most sophisticated digital twin in the world is useless if you don't have trained engineers and technicians who understand how to interpret the data and physically implement the optimizations.
It really pulls the core themes of this deep dive together. We started by questioning how a 178-year-old industrial company could possibly decouple its financial growth from the physical resources it consumes.
And we found the answer.
We did. What these sources reveal is that modern sustainability has moved far beyond public relations campaigns or soft corporate social responsibility buzzwords.
It's all data now.
It is a hard-nosed, highly measurable, data-driven business strategy. By leveraging industrial AI, digital twin simulations, and circular manufacturing models, a company can aggressively shrink its operational footprint while exponentially growing the handprint it leaves on the broader global economy.
It represents a fundamental rewiring of the industrial landscape. But before we conclude our analysis of these reports, I want to draw your attention to a particularly fascinating concept buried in the 2040 Outlook section of the sources.
Oh, the Outlook section. What did you find?
It offers a glimpse into where all this data is ultimately leading us. The projections estimate that by the year 2040, we will have a global population of 9 billion people living in a highly connected, deeply electrified world.
Okay.
The vision they outlined isn't just about infrastructure becoming smart in the way we understand it today. They're projecting a future where infrastructure becomes entirely autonomous and self-healing.
When you say self-healing, you mean taking the predictive AI we talked about with the water networks and essentially removing the human maintenance entirely.
Exactly. This raises an important question for you to mull over. Think about the digital twins and the AI optimizations we've unpacked today.
Okay.
What happens when the buildings we live in and the massive energy grids we rely on use that AI not just to alert a technician, but to predict their own mechanical failures, automatically reroute their own energy flows in real time, and essentially breathe in perfect sync with the natural environment without any direct human intervention?
Wow.
If a municipal power grid can autonomously route around a severe storm, or a city's water system can physically seal a micro leak the exact millisecond it detects a drop in pressure,
Wow.
how will our daily lives fundamentally transform when the invisible infrastructure that surrounds us finally takes care of itself?
That is a brilliant and slightly surreal vision of the future to leave things on. Thank you so much for joining us for this deep dive into the mechanics of industrial sustainability. We hope you walk away with a clearer understanding of how the digital and physical worlds are merging, and perhaps a few new aha moments about the hidden software running the world around you. Until next time, keep questioning, keep learning, and we will catch you on the next deep dive.